but effectively it's empty. It's empty of zeros and ones. Okay. So using that, detecting the dollar to mean that your stack is effectively empty, no zeros or ones in it. That's the trick. Okay, that's how you you don't need something extra, some special thing in the definition to detect whether a stack is empty. You just use this dollar trick. Okay, it could be any symbol you like, but just use a dollar. Right, so that's what it's for. It's a trick to enable the PDA to know whether the stack is empty or not. Okay? It's empty if it sees the dollar on the stack, at the top of the stack. Okay. Now similarly, the PDA strictly, you don't know that it has no explicit way of detecting that it's at the end of the input string that it's reading, but implicitly, because of if you're in an accept state, when that last symbol of your input string goes in, then that will signal that the string has been accepted. So effectively it's the same. So that way you do know that the string has ended. Okay, which is what has been said here. Now, beginning with the next example. Now, before I get on to that, I'm still left with a question, or several questions, but all the same nature. I'm still not, given what's been said so far by Sipser, I'm still not clear on how to use the stack in the sense of make if you're overwriting, how do you... I suppose you're writing when you see here. I'm thinking in real time here, right? My question is, how do you get all the members of a stack to move down one position? Or how do you make them all go up one position? That's still not clear to me in terms of this formal definition. But I'm just thinking now, if this C is epsilon, the empty string, so what would that do? So we just leave the top one blank and all the other ones below it just the same. But how do you push? How do you make the ones below move down one? How does that work? I'm still not clear on that. So well, here's another one of these cases. So think about it. See if you can find the answer, because I'm left with a question mark on that. How do you push and pop? How do you get the whole stack to move up or down one position? How is that implicit in what's been said so far? I guess so, but not clear to me. Hopefully it'll come a bit later. All right. Now to finish off this session on the board, we start our second example of the use of a PDA. So what do PDAs do? Well, they recognize languages. Right? They can recognize non-regular languages. They're more powerful than finite automata because they can recognize some non-regular languages. And I guess here this is an example of one. So here's the language you're asked to recognize. Okay. So the strings have the form A to the I, B to the J, C to the K. These are just integers, non-negative integers. Right? And there's a condition, either I equals J or I equals k. Now when I first wrote this down, I just instinctively put a j here, because that's what we've done earlier, right? But no, don't be fooled, right? It's not a j, it's an I. So either this number here, I equals j, or I equals k, right? It's not j equals k, which is what we had earlier, somewhere in some earlier session. Okay. So now informally, what's going on? How will this work? Well, it's going to push all the A's onto the stack, right? And once it's done that, so it's pushed all the A's, then it, in a sense, with its infinite memory, it has a memory now of effectively the number of A's that are on the stack. And then it'll try to match that number of A's with either the number of B's or the number of C's. Okay? Trouble is, this machine doesn't know whether it's to match the A with the B's or the A with the C's. Well, that's probably a clue to you. Okay? Use non-determinism. Have branches of this PDA. Like, every time it branches, you create a new copy of the PDA and put it in a different state, I guess, and maybe also the stack, top of the stack maybe, and then just have these two PDAs independently going down different branches, right? This PDA, we've been saying from now on, the PDA is a non-deterministic machine. Okay, so you can have copies of it independently going down different branches in your tree of states, your history, if you like. Okay. So left here with a question: how do you match the A with the B's, or do you match it with the C's? And I've given you a strong hint: use non-determinism to investigate both possibilities at the same time. Right? So think about, how do you push and pop? I'm still puzzled by that.